All right. We could do recording to the computer, see if that saves it. Uh, um, there we go. Okay.
I can start this time because my laptop is at fucking 24 and this thing has 45 minutes left, just in case.
Yeah, that's fine. Just go for now. I'm just gonna keep the presentation like this because I feel like if I do the slideshow, it's going to it's going to freeze up my computer again.
Okay.
No worries.
All right. It's recording, so go ahead.
All right.
Right.
So we did stock versus modified engines. The objective of this was to take a stock Predator engine, which you can buy from Harbor Freight, and make simple modifications such as intake and exhaust, and make these modifications with the hope of increasing horsepower. Um, the key question that we try to answer from this was how do the exhaust and intake modifications affect the horsepower of a Predator engine? So, for background and previous work, um, the three of us really don't have a lot of background with this particular pony brake setup or even engine testing, I guess. So we had to do a lot of research in advance to figure out what a pony brake was and how to use it and how to actually get horsepower and torque figures out of a pony brake. Um, we're all interested in engine modification, which is what led to us all working on this project together. So engine testing is a big thing in the automotive world, I guess you could say. And pony brake testing has been done before. I don't think it's been done a lot on these smaller Predator engines, at least in the modern world, maybe a long time ago. Um, but it's a very essentially simple and effective way of measuring horsepower. If you don't have the resources to have a real dyno setup, so it can be used on a lot of different uh, applications. So for test plan, obviously the first step is we needed to figure out what materials we needed, and we needed to figure out what kind of intake and exhaust systems we needed, and we need to figure out if they were gonna fit our particular engine. Um, we had to construct the pony brake system. We had just from images off Google and other websites, we were able to get a rough idea of how we had to make it. Obviously, we didn't have any dimensions or anything. We just kind of went off of what we had. Um, we the other thing was we had to find a way to actually record our results. So we used Excel in order to record all the horsepower, the torque readings, any other readings we needed, uh, and then obviously we had to actually uh, fit the exhaust and intake systems onto the engine. For test equipment, first one obviously is the pony brake. The pony brake is essentially two pieces of wood that are cut out to fit a round metal rotating wheel. Um, and it's held together by two long metal pieces of rod with a piece of metal bar that runs along the top with two springs and two nuts. We also obviously needed the Predator engine, which we were able to get from Harbor Freight. The tachometer we were able to get from the speed shop, and the frame that the engine sits on, we built ourselves, and the pony brake we also built ourselves. The engine frame allows us to test the engine in a safe way without just having the engine sitting on a surface without any support. So for measurement, like I mentioned before, the pony brake is essentially the main device to measure the horsepower and torque. The little other things such as the tachometer, you need the tachometer in order to read the RPM readings. Once you know the correct RPM reading, you're able to figure out other numbers such as torque. Once you find torque, you find horsepower. Then you can plug that all into Excel, and you can clearly see whether or not your intake and exhaust modifications were actually creating a difference in horsepower. This is just a overall view of what our experimental setup looked like. So obviously the engine is sitting on the wooden frame that we built for it. In this particular picture, it has the intake modification already on it. On the backside of the engine is where the rotating metal wheel is. That is held together, or not held together, but clamped together by the pony brake. You can actually see the metal rod that runs along the top of the pony brake, and the piece of wood sticking out the side is mainly a safety factor, just in case something was to go wrong. That piece of wood allows for that metal rod not to go flying somehow.
Right, so for risk assessments, the main ones were mechanical hazards and spills. So in terms of mechanical hazards, obviously we have an engine running, so there's moving parts. There's going to be high noise levels and your exhaust fumes. For fuels, we have gas and we have oil, so those may spill, and if they're hot and it catches on someone, it could cause burns. Also, if you touch the actual exhaust itself, that could burn you. To mitigate these, we wore PPE, so personal protective equipment. We made sure to do all testing in a well-ventilated area. So for us, that was outdoors. And then we just maintained a safe distance from anything that's hot or moving. And then we kept in mind that the modifications that we do, if we don't install them properly, they could cause harm to the engine. So we made sure to follow all the installation instructions, pretty much to a T. And then we conducted all of our tests in as controlled of an environment that we could. This is the schedule that we kept. This isn't all of it, but this is the most important stuff and the main things. So a lot of it on here is just research related stuff, and then since I want to say a couple days before the 5th and pretty much a couple days after that was just testing. This is the budget that we boiled it down to to start. It's pretty accurate with the exception of the gas tank and the header pipe. We never bought the gas tank with the fuel gauge or the header pipe, mainly just due to timing and shipping. Everything else though is accurate. We did buy the engine, obviously. We had the intake system, and then we built the pony brake stuff as well. This is the stop motor. That's what it looks like, and then those are the specs for it. And then this is the intake system that we added. So pretty much by changing the intake, we allow more air to get into the motor, which produces more power, and also helps the motor run more efficiently. So those are the benefits of having that installed. In terms of the exhaust, because we didn't have the exhaust system that we wanted, we just ran an open header, so essentially no exhaust at all.
All right, these are the results for just the stock engine itself with no modifications. As you see, we ran at different RPMs of 2,000, 2,500, and 3,000, and at different torques. And the horsepower equation that we used was torque times the RPM and divide that by the factor of 5,252. And as you see at different RPMs and at different torque, we received those horsepower. And as a stock motor itself is about 6.5 at 3,000 RPMs and with 11 pound-feet of torque, we achieved 6.2 horsepower. These results include just the modified intake, not the open header. We ran this test at different RPMs as well, from at 2,000 and at 3,500. And of course, with different torques from 8 pound-feet of torque and 11 pound-feet of torque. And again, we're still using the same horsepower equation. As you see, the horsepowers are increasing with the torque and increasing with the RPM. We were able to achieve a net increase of 0.83 horsepower at 3,500 RPM with 11 pound-feet of torque. These results include the intake plus the open header, again at different RPMs and same torque as before. At the highest level RPM 3,800 with 11 pound-feet of torque, we were able to achieve a net increase of 1.45 horsepower increase from the stock configuration. The overall results, like again, just to reiterate, the max horsepower at stock is 6.5 horsepower. With the intake modification, we were able to achieve 7.33 horsepower, an increase of 0.83. With the open header and intake, we were able to achieve 7.9 horsepower, which is an increase of 1.45. And with the modified parts, we were able to achieve our hypothesis result of 1 to 1.5 horsepower increase. And that's everything. All right.